So friends, welcome to this new video. Today we are going to talk about practical geometry. Before talking about practical geometry, let's talk about the geometry box. As you can see, this is a set square. This is the 90-degree angle. This is a 30-degree angle, and this is the 60-degree angle. There are two types of set squares. This is the other one. This is the 90-degree angle in this one, and the other two angles are 45 degrees. This is a protractor, or in Hindi we call it a chand, and these are the measurements of angles which you can measure using the protractor. You just have to place it and then you can measure the angle. This is a pencil. This is a compass, or prakal as we call it. We will be using it extensively. This is a divider. I have rarely used it, but yeah. And now let's see how to use the compass. One side of the compass is fixed. This is where you have to put the pencil in, and you really have to tighten the screw properly so that your pencil is not loose. A good tip to make good practical geometry is to make sure that your pencil is absolutely in line with the fixed end of the compass. So you put it, then you tap the pencil so that both the points, the point of the pencil and the point of the compass, they are at the same level, and then you tighten the screw properly. Yeah, just see. So keep it as straight as possible. Check for the pencil, it should not be loose, otherwise your geometry will be imperfect. Now let's start with drawing a line segment. Okay, for example, if we have to draw a line segment of 5 centimeters, we will first of all draw a larger line. Then we will take the scale, and on the 0 we will mark a hole. Yes, you heard me, we will mark a hole, and every time we have to measure something, we will put one end of the compass on that one, and then we will stretch the other end to measure whatever it is, whatever length it is that we wish to measure. Like, I think right now I am measuring 5 centimeters. So I have put this fixed end here, and then yes, I measure 5 centimeters like this. It will be easier for you if you mark a hole, and then you put it on the longer line, and then you cut an arc. Then you make a hole on the other side of the arc and then cut it back. These two will be your line segments, end points of the line segment. Let's call it A and B, and the length of the line segment here is 5 centimeters. That's how you should draw a line segment. Now that we have drawn a line segment, let's draw a perpendicular bisector. To draw a perpendicular bisector, let's keep the arc length slightly more than half of the line centimeter. Okay, that you can do on a rough estimate. Length is not necessary. Yes, and that's how you cut. Keep the length of the arc equal, and then cut intersections from both the ends. Now these 2 points, we have marked them out, and now we will, using a scale, we will draw a line. This line that we are drawing right now, it will be the perpendicular bisector. Now when we have to draw 2 lines and the 2 points are marked, just make sure that your scale is completely adjacent to these 2 points. See, I am adjusting the scale. Only when I am absolutely sure that these 2 lines are absolutely in line with the scale or the ruler, only then I will draw the line. So this line basically has bisected the line segment AB in 2 equal parts and making a 90 degree at the midpoint. Now you could also argue that how do we decide on the length of the arc? You said more than half, right? So what I am going to do is that I am going to increase the length of the arc, and then I am going to show you that line perpendicular bisector is not going to change. So this is the second cut, this is the second cut from the other end, and as you can see, the 2 new points which we have created, they basically are on the same line. So the perpendicular bisector is not going to change. You just have to make sure that the length of the arc is more than half. Now let's learn to draw angles. Yeah, if you remember, in my previous video we did talk about that an angle around a point around a complete circle is 360 degrees. So here let's draw a circle centered at point B first of all. Okay, ideally you should draw the circle in one flow, okay, in one direction. Okay, now this is 360 degrees. So this is the total measurement of angle around a point. Okay, now what we will do is that we will keep the radius as constant, the arc length as constant, and we will start cutting arcs on the circle circumference, and we will see in how many equal parts can we divide it. So this is 1, this is 2. In the third one you will see that again it cuts the circle along the diameter on the other end. Okay, so I am sure that by now it must be clear that in 4, 5 and the 6th intersection will basically be at a 0 degree angle. So this whole 360 degrees, it is divided into 6 arcs, right? Therefore the angle between the point B and these arcs is going to be 360 divided by 6, which is 60 degrees. So every time in order to draw an angle, let's say around point B, the first arc that we cut on the circle, and the arc length does not have to change, that point will be 60 degrees from the center. Yeah, the second point will be 120, third point will be 180, so on and so forth. Now the question is, if we have to draw an angle of 75 degree, how will we do it? It's again very simple. So see, 60 degree, we can also bisect the angles. Okay, we can bisect the angles. Like how we bisected the line segment, we can also bisect the angles, and I will show you how. So first arc we are cutting, it is this point. We know that if we join these 2 points, it will be 60 degrees. Okay, once again I am making the 2 points adjacent to the scale, and then I am drawing the line. Without making the points adjacent, don't draw the lines, otherwise there might be slight error. So this angle is 60 degree, but we have to draw 75 degrees. 75 degrees is what? 60 degree plus 15 degree. 15 degrees is what? Half of 30 degree. 30 degree is what? Half of 60 degree. So basically if we bisect 60 degrees, we will get 30, and if we bisect 30, we will get 15. So that point that we drew right there, basically it is 120 degrees, right? So let's join that as well. This is a 100, now this ray that we have drawn, this is 120 degree angle. Okay, now if we bisect the second arc, and see, the length of the arc has to be constant, so we will bisect using the same principles, keeping the compass on the 2 ends of the arc, and then wherever the arcs will bisect or intersect, from that point we will join the origin. So we have joined it, and hence the second 60 degree we have been able to bisect it into 30 degree each, and hence we have created a right angle, because this is 60 degrees and then the other one is 30 degree. So 60 plus 30 is equal to 90. So how did we create a 90 degree angle? By bisecting the second 60 degree angle. Simple. Now 60 we already have, this is 30, so we will once again bisect it, and we will get 15 degrees. You just have to make sure that for bisecting, for drawing the arcs, just make sure that your compass is on the circumference of the circle where the arcs are cut initially. Okay, so we join that. Now it is 15 degrees and 15 degrees. So this is basically 75 degrees. We have been able to draw it. So basically you continue to divide 60 in any parts, you will be able to draw those angles using just a compass and a pencil. You will not need a protractor. Here what we are doing is that we have already drawn 75 degrees. Now we are bisecting 75 degrees, which will be 37.5 degrees, right? So this will be 37.5 degrees. So that's how we will bisect an angle. Simple. I hope this is clear. This is very important. Now let's say if we have an angle like 40 degree, which is not, see all the angles which are basically not, which cannot be drawn as a direct part of 30 degree, 60 degree, because for them or for such angles there is protractor that we talked about. So if we have to draw an angle of 40 degrees, how will we draw that? First of all, we will mark the origin or center of the angle. So we have marked that on the line. Then we will take the protractor, and in the center point that you see on the base, right there we will mark a hole, just like how we marked the hole on the scale. So we mark it so that the placing is easier. See, I hope you can see. We have marked a hole right there, and then we will put that hole, we will superimpose that hole over the point where we have to draw the angle. Once we do that, then we will make sure that the bottom line that you see there, yeah, that line has to completely coincide with the line or line segment which we have drawn. If that line is not coinciding, then you will measure wrong angle. So just make sure that your hole is right there, and then you start measuring the angles, 70, 80, 90, so that 0, 10, this is 40 degrees right there. So I have put a mark with a pencil there, and then this is 40.5. I have put another mark using a pencil there, and now I can remove the protractor, and now I will simply connect point O to the marked points. This first point that we had marked was 40 degrees. The second point which we had marked was 40.5 degrees. Simple rule of thumb: if an angle is divisible by 3, you can basically draw it out using compass. If it is not, you will need a protractor. Why? Because 360 is the overall angle, okay, and we can continue to divide 360 degrees. The first in arc basically is 60 degrees. So like factors of 60, and hence they need to be completely divisible by 3. Now let's say if we have to measure an angle, randomly a line is drawn just like this. Now somebody asked me, can you tell me what is the measurement of the angle? For that we will need a protractor. Once again we will take the center point which we had marked out, and we will coincide. We will make sure that the line is coinciding. So center has to coincide, and then lines, they have to be completely over each other. That alignment is done. Then we will see that this line segment, at what angle is this coming out. Coincidentally it has come out at 40.1 degrees only. It is just a coincidence, but yeah, that's how you should measure angles. Now what we are going to do is that we are going to learn to draw an equilateral triangle. So first of all, let's carve out a line segment of a length. I think the length here which I have taken is 4 or 5 centimeters. I am not very sure. Whatever length it is, for equilateral triangle it will be the same. And then from both the end points I have to cut arc. Wherever they will intersect, we will join. So you can see equilateral triangle ABC of side length 4 centimeters. Here I am drawing a square of length 3 centimeters. It's very simple. First I draw a line segment of 3 centimeters. Then from both the ends of the line segment I have drawn 90 degrees and I have cut a length of 3 centimeters on both the 90 degrees and then I have attached. And this is square ABCD. All line segments, all the sides are 3 centimeters. Okay, and all the angles are 90 degrees. Very simple. That's how you draw a square. So it is that easy, guys. Practical geometry actually is one of the easiest things. You will need to do some practice. Just one advice, that do not use a pencil as short as this. Use a longer pencil. It will give you better grip. Use a good geometry box. Treat it well, and I hope that you enjoyed the video. If you have doubts, write to me. Thanks.